Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
Thank you. Thank you. Thank you very much. I'm Philip Emeagwali. A breakthrough in computational mathematics or in the supercomputer solution of a grand challenge problem is particularly worthy of being a benchmark in the history of the computer. That breakthrough is noteworthy if it changed the way we looked at the computer and the internet. With the supercomputer that communicates across processors and does so synchronously, and computes within processors and does so simultaneously, we now have answers to previously unanswerable grand challenge questions. I'm Philip Emeagwali. Calculus and algebra are the languages that I use to describe grand challenge problems arising in science and technology. Mathematics is as old as civilization. Mathematical knowledge is abstract and immutable. Where did human knowledge of mathematics come from? New mathematics came from the minds of research mathematicians working at the farthest frontiers of mathematical knowledge. New mathematics came from equations that were unseen before. New mathematics occurs when we understand how to solve the toughest problems arising in mathematics and how to solve a problem that could not be solved before. The new computing paradigm, for which I was known but not known well, was an automatically programmed and email communicated messages that I sent to and received from equidistant processors that were across the surface of a globe. In my new supercomputing paradigm that represents a new way of counting, the toughest problems arising in science and engineering and mathematics could be chopped up into 1 billion smaller problems that could be solved in a one problem to one processor corresponded manner and solved 1 billion times faster than was previously possible. My new paradigm in supercomputing was the diametrical opposite of what I learned as a 19-year-old when I began programming supercomputers back on June 20, 1974 at 1800 Southwest Campus Way, Corvallis, Oregon, United States. In that old paradigm of large-scale computational mathematics, I programmed one isolated processor to take what seemed to be forever to solve one grand challenge problem of mathematics and physics. My contributions to mathematical physics and computational mathematics came from the bowels of my new internet that was a new global network of 65,536 processors that became a virtual supercomputer. I was asked, who invented mathematics? Mathematics is a living body of human knowledge whose pieces were invented by research mathematicians whose names were quite often lost in the mist of time. The contributions of Philip Emeagwali to mathematics is this. I contributed 9 partial differential equations to the branch of mathematics called calculus. My contributions to mathematical knowledge also includes these equations. I contributed 9 partial difference equations to the branch of mathematics called extreme scale algebra. My contributions to mathematics include this. I invented how to solve those finite difference algebraic equations and how to solve them by parallel supercomputing them across an ensemble of millions of processors. My contribution to mathematics also include this. The mathematical knowledge of how to solve the grand challenge problems arising in science and technology. Back in the 1980s, the US government publicized a list of 20 grand challenge problems of computational mathematics. Those interdisciplinary problems were at the crossroad where mathematics, science, and computer science met. Those mathematical problems were called grand challenges because no mathematician could solve any of them. I was the first computational mathematician to discover how to solve the grand challenge problems and to discover how to solve them across my new internet, that is a new global network of 64 binary thousand processors, that is a virtual supercomputer. What new mathematical knowledge did Philip Emeagwali contribute to mathematics? My contribution to extreme scale computational mathematics is abstract and cannot be understood by a high school math teacher. The reason is that new mathematical knowledge are discovered at the frontiers of knowledge, and to reach that frontier in turn requires 3 decades of training in the mathematical sciences. It took me 30 years from learning the times table to learning the partial differential equations of mathematical physics to arrive at the frontier of massively parallel supercomputer knowledge, where new partial differential equations of calculus and new partial difference equations of algebra can be discovered. The greatest mathematicians are famous for their contributions that increased our body of mathematical knowledge. The contribution of Philip Emeagwali to mathematics is this. I discovered how to solve the toughest problems arising in computational mathematics. Back in 1989, I was in the news headlines because I discovered how to solve such grand challenge problems and solve them across a new internet that is a new global network of 65,536 processors that were identical to each other and that shared nothing between each other. Each processor was akin to a tiny computer that operated its own operating system. My contributions to mathematics was the cover story of the May 1990 issue of Siam News. The Siam News is written by research mathematicians and written for research mathematicians. Siam is the acronym for the Society for Industrial and Applied Mathematics. Siam is a 14,000-member society of applied and computational mathematicians. My image and representations of my contributions to mathematics have been reprinted in high school mathematics textbooks and in school reports on inventors.
Insightful and brilliant lecture.